everyone. Hope you are all good. Alhamdulillah, we have completed the lesson. Almost four lessons we are completed. Now we're gonna move to the next lesson. Before that, I just want to recall all the four lessons. Okay, the first lesson is called Nature of Physics and Measurement. In this lesson, we have learned about the basics units. What is meant by physical quantities, what is meant by derivative quantities, and fundamental quantities. All those things we learned after we move on to the next one, the dimensional analysis. Okay, before that, what is mean by measurement and what is mean by errors. Okay, errors are one of the important. How we have learned what are the errors will be occurred and how we can minimize that error kind of errors. After we learned the dimensional analysis, which is very important for your higher studies, how the dimensional analysis and the three basic quantities describe all the quantities in nature. Okay, so on the second lesson we learned about kinematics. The kinematics is nothing but the motion of the object or position of the object with respect to the frame of reference, but without force we are taking or we are dealing with the lesson. Okay, in this lesson we are not at all taking that force into the account, but we are dealing the motion of the object. We are dealing that motion of the object. In this lesson also we learned about the centripetal acceleration, which is very important. When the uniform motion, the centripetal acceleration which is act towards the center, a is equal to minus v squared by r. Okay, after we compare that kinematic equations for rotation motion and translation motion. The third lesson, laws of motion, which is nothing but the motion of the object with respect to the force. What happen if the force is applied on the object, how the forces will displace that object. All those things we learned. And also in this lesson we learned about what about the Galileo idea, and what about that Newton's idea, and what about the Aristotle idea. In this lesson also Newton said very clearly, the force is required when there is a change in momentum. When there is a change in momentum, force must be needed. Okay, F equal to dp by dt. Whenever there is a change in momentum, force must be needed. And also in this lesson we'll deal with that Newton's three laws and inertia of the direction, inertia of the rest, and inertia of the motion. After we learned about that friction forces. Okay, what are the friction forces? Static friction, kinetic friction, rolling friction also we learned. After we learned about the centripetal force and centrifugal force also, which is very important. Centrifugal force is always acting in the rotating frames. Okay, and fourth lesson, when come to the fourth lesson, work, energy and power. What is meant by work and what is meant by power, what is meant by energy, everything we learned. After in this lesson also we learned about that collisions, which is very important. There are two type of collision, elastic collision and inelastic collision. Elastic collision, the energy will be conserved. Inelastic collision, there is a kinetic energy will not conserved. Okay, the next lesson, the motion of system of particle and rigid bodies. Okay, in this lesson we gonna learn about what happen if the equal mass distributed to the object. Okay, what is mean by center of mass, how the center of mass will be act on the object, and what is meant by torque, and what is meant by angular momentum. Okay, in the lesson we are much more dealing there with the motion of an object within the rotational frame, which in the rotational motion. Okay, what is meant by translation motion, what is meant by rotational motion, everything we're gonna learn. And also we're gonna learn what is the type of equilibriums, okay, acting on the rigid bodies, and dynamics of the rotation of rigid bodies, and translation motion, rotation motion, rolling motion. What happen if moving, sliding and slipping? During the sliding and slipping, what will the forces will be acting? All those things we gonna learn in this lesson. Okay, most of the object when we come across the one day to life consist of large number of particles. In the previous units we studied the motion of the bodies without considering the size and shape. So far we'll have treated even bulk bodies as only the point object. In this section we will give the importance to the size and shape of the bodies. These bodies are actually made up of the large number of particles. When such a body moves, when we consider the as motion in the collection of the particle as a whole. Okay, in this lesson we gonna deal with that object with the whole body. Okay, the particle which is have the large number of particles. Okay, so all the particles we gonna consider. We define the concept of the center of the mass, deal with such a system of the particle. Okay, the forces acting on these bulk bodies are classified into internal and external forces. Internal and external forces. Okay, so among these forces, okay, internal forces are the forces acting among the particles within the system that constitute the body. External forces acting on the particle of the system from the outside. Okay, we know that we have the two type of forces, which is one the internal forces, which is the motivating. Okay, for example, the internal forces, we have to do that work, so internal forces. External forces, you have to do that. Okay, when I'm ordering you, when I'm pushing you, that's external forces. Okay, so here the when the object is there, there must be two forces will be acting. Inside the object there is a lot of particle which is acting on it to move the object. Okay, so that is called internal forces. External forces, when you are making to move the object, that is called external forces. Okay, we deal with such a system of the particle which make the different bodies. A rigid body is the one which will maintain its definite and fixed shape even when the external forces acting on it. Okay, so even the external forces acting on it, it must be maintained its definite shape. Okay, so this means interatomic distance do not change the rigid body when an external force is applied. However, in real life situation, we have bodies which are not ideally rigid because the shape and the size of the object or size of the body change when the forces act on them. For the rigid body we studied here, we assume that such a deformation are negligible. This deformation produce a non-rigid body studied in the properly in the unit 7. Okay, elasticity of solids, that means. Okay, now what is mean by center of mass? When the rigid body moves, all the particles constitute that body that need not to be take the same path. It depending on the type of motion. Different particles of the body may take the different path. For example, when the wheel rolls on the surface, the path of the different point of the wheel and the path of the other points of the wheel are different. In this unit, we'll study about this translation and rotation motion and combination of these motions of the rigid bodies. Okay, what is mean by center of mass? Okay, so center of mass is in the rigid body. Look at the picture. When the boys pull out that, when the boys is thrown the bat goes in the circular motion and also takes in the parabolic. Okay, when the it takes the parabolic motion, all the points in the red color line, okay, the red dotted lines, that is called center of mass. Center of mass of an object will have the maintain the same motion. Okay, the point mass is the hypothetical point or particle which is have the non-zero center of mass. What is mean by center of mass? Center of mass is nothing but the whole object, the whole mass of an object with act in the center of the object, which act on the center of the object. Okay, the center of mass of the body defined as the point where the entire mass of the object appears to be concentrated. Okay, so the equations of a coordinate system. If the center of xcm is the center of mass acting on the object, then is the summation of mixi, mass of the object, and center of the distance between the object. Okay, the total summation of mi is called the total mass of all the particles. So summation of mi we can write m capital M. Okay, so if it's acts, we can also find the y and x. If it's act in the y coordinates or z coordinates, then we can take it as y into center of mass and z center of mass. The position of the center of mass of these point Cartesian coordinate system xcm, ycm and zcm. Okay, in general the center of mass can be written in the form of rcm equal to summation of mi by total mass. rcm is the combination of summation of xcm I vector plus ycm I vector plus zcm I k vector in the position vector. The center of mass will be given xi plus yj plus zk. The position vector are distributed I, j, k coordinates. So x, y, z along the x, y, z axis. Okay, so what will happen if the center of mass, or what will happen if the forces will be acting on that object, and what will happen if the rigid body having this more if the rigid body having the large number of center of masses, if the masses is not uniform in the rigid body, what will happen? Center of mass will not lies on that geometrical center. Okay, center of mass will not lie on the geometrical center. It lies on the either on right side or left side. Either is right side or left side. Okay, so mass distributions, and then when the rigid body, okay, moves, the center of mass also moves along the body. The kinematic equation VCM will be given. Okay, look at the picture. The VCM equal to velocity summation of mi va by summation of mi. Acceleration is summation of mi ai by summation of mi. Okay, when the absence of external force F equal to 0, the individual rigid body of the system can move or shift only due to the internal forces. This will not affect the position of the center of mass. This means that the center of mass will be in the state of rest or uniform motion, hence VCM will be 0 when the center of mass is at rest and constant. When the center of mass has uniform motion, VCM equal to constant. Okay, 0 or constant, there will be no acceleration of the center of mass. Okay, when we know that what is meant by acceleration. Acceleration is nothing but rate of change of acceleration is nothing but rate of change of velocity. So whenever velocity equal to constant or 0, then what will happen? 0. Acceleration will be 0. Okay, suppose it's a constant, it's only 1, think about that, this is 6. Okay, what will happen if you're doing the differentiation for the constant? It will give the value of 0 only. So the acceleration will be 0 when the velocity will be constant, or when the velocity will be 0, when the velocity will be equal to 0. Okay, now and also note it down, this is very important. Okay, and the presence of external force, what will happen when the external force is not equal to 0? The center of mass of the system will accelerate as given the following. So this is also important one thing. Okay, F external will be equal to mass into acceleration, we know that, right? F equal to ma. So F external forces will be equal to mass into acceleration due to the center of mass. So acceleration due to the center of mass will be equal to force per unit mass. Okay, the next one thing I'll teach you while I'm the live class, that board sum. Okay, center of mass in the explosions. Many times the rigid bodies are broken into fragments if then explosions are caused by the internal forces in a body which is at rest or in motion. The state of the center of mass is not affected. It continues to be the same state of rest or motion, but the kinematic quantities of the fragments get affected. If the explosion is caused by an external agency, then the kinematic quantities at the center of the mass as well as fragments will get affected. So look at that one picture. See, the object of the bomb, okay, is nothing but your explosion bomb, is thrown on the center of the body. If it is 5 kg, what will happen? The 3 kg will be drawn at this point when the distance from the point when the bomb is thrown on the surface. Okay, what will happen from the origin to the center of mass? The distance equal to r. From the origin to the other point, 2 kg will be dropped there, so that is distance will be d. So the total distance will be equal to r plus d. So m1 x1 will be equal to m2 x2. So what will happen? M1 is the 3 kg and M2 will be 2 kg. X1 equal to 1 by 4 R. X1 1 by 4 of R. X2 will be equal to D. Okay, so this is how we can deal with this lesson. Now, torque and angular momentum. This is important one of the 3 mark question. What is the relation between torque and the angular momentum? They will ask. Okay, torque and angular momentum. When the force acts on the body, it produces the linear motion in the direction of the applied force. If the body is fixed to the point or at such axis, such a force rotates the body depending on the point of application of the force on the body. The ability of the force to produce the rotational motion in a body is called torque. Note it down. What is meant by torque? The ability of the force to produce the rotational motion in a body is called torque, or it is called moment of inertia. So exams, there is a lot of examples are there. The motion at the plenty in the day-to-day life. To mention the few, the opening and closing the door, about the hinges, and turning the nut using the wrench. Okay, these are the good example for torque. And the extended rotation depends on the magnitude of force. Note it down also. Its direction and the distance between the fixed point and the point of application. When the torque produces the rotational motion in a body, its angular momentum changes with respect to the time. Okay, so here look at the torque on the rigid body. Product of R, okay, the product of R, that means distance, and F is called vector product or cross product. So torque will be equal to R cross F vector. R vector cross F vector. Tau vector equal to R vector cross F vector. The vector product of two vectors are resultant in another vector perpendicular to the both. So torque will be equal to R vector cross F vector. So both are in the cross product. So we can write it in the form of sin theta. Okay, r of sin theta into n cap. Here theta is the angle between the r vector and f vector, and n cap is the unit vector in the direction of the torque vector. The torque is the sometimes it's also called pseudo vector. As is needs the other two vectors r vector and f vector for its existence. The direction of the torque is also found using the right hand rule. This rule says that the fingers of right hand kept along the position of the vector with the palm facing the direction of the force. When the force fingers are curled in the thumb points direction of the torque. Okay, so how it's happening? This is your right hand. Okay, think about this one right hand. Okay, the position of the vector palm facing. Okay, this is your palm facing. So here the forces will be acting, and the curved point, in this curved point, here your torque will be acting. Here your torque will be acting. Okay, so the direction of the torque help us to find the rotation caused by torque. For example, direction of the torque, this is the torque. Okay, direction of the torque in paper, out of the paper, then the rotation produced by the torque is anti-clockwise. Okay, note it down. The rotation produced by the torque will be anti-clockwise direction. And in many cases, direction and magnitude are found in separately. For a direction, we have to use the vector rule or right hand rule. For magnitude, we use the scalar forms. Okay, tau equal to r of sin theta. The expression for the magnitude of the torque can be written in the two ways by associating the sin theta. So tau equal to r of sin theta or f vector, perpendicular distance. Okay, or tau equal to r sin theta or f vector outside. Okay, so when we take the constant, r into perpendicular distance into f vector. So here f sin theta is the component of the f perpendicular to the r. So component of the perpendicular in the two cases. First cases when there is looking this one. So look at the picture, calculating that torque effect, how the force is acting, how the distance will be calculated. Okay, so when the torque will be maximum, when the theta equal to 90 degree, when the sin theta equal to 90 degree, it may be once. So torque will be maximum rf. The torque will be 0 when the is parallel or anti-parallel. Then that means theta equal to 0 degree or 180 degree. Okay, so when the sin 0 will be 0, sin 180 degree will be equal to 0. So the torque is 0, the force is acting on the reference point at least r equal to 0 or tau equal to 0. The different cases will be shown. See the value of tau for the different cases. When the theta equal to 90 degree, tau will be maximum. That means torque will be maximum. When theta equal to 0 or that parallel to the force, then torque will be 0. Anti-parallel, that also will be 0. When r equal to 0, then that when there is no distance, then torque will be equal to 0. And also this one of the important sum, the crane sum. It is called crane sum. Torque about an axis. Okay, what happened if an rotation of axis, what will happen to the torque? Okay, and also we know that Tamil Nadu known as for creative or innovative traditional games played by the children are such very popular some silly at Silicode. There is a rectangular area which is a further partitioned as seen figure. One has to hope through the rectangles while doing the children learn on the on side. So what is mean by that? What is the reason acting on that? Naturally, body takes the position to balance the gravitational force mg and normal force n acting on the body and nullify the torque. Okay, so the gravitational forces on our body is acting on the abdomen, so that nullified by the torque. Falling which failing which both these forces will act on the different lines. Okay, when suddenly when someone is being unconscious, why he is falling down means this is the torque. Okay, because there's a certain forces will be acting, so the center of mass will be displayed. So when there is a no center of mass is acting on that object, the gravitational forces will be zero, so there will be a torque effect produces, so the body will be that means that person will be fall down. Okay, so in leading to the net torque, which makes one to fall. The torque force about an O, torque tau vector will be equal to r vector cross f vector. The component of that torque along the axis of the torque of f vector about the axis. To find it, we should first find that vector r vector equal to r vector cross f vector. To find an angle pi between the tau and the AB, the torque about AB is parallel component and the torque along the AB, which is r modulus of r vector cross f vector cos pi. Okay, but torque perpendicular to the axis AB equal to r vector cross f vector into sin pi. The torque about the axis will rotate the object about it, and the torque perpendicular to the axis and will turn the axis of rotation. When both exist simultaneously on the rigid body, the body will have the precision. Okay, precision we learned in that first lesson itself. Look at that one. Precision is means that accurate. Okay, that means exactly where the center of masses and center of gravity will be acting, and the rotation motion will be taking in these places. Okay, so precision is beyond the scope of the higher secondary physics course, and assume that the constraint is called effector perpendicular components of the torques, so that the final position of the axis is maintained. These examples I will teach you by live class. Okay, this is important one thing. Torque and angular acceleration. Okay, what is mean by torque and angular acceleration? When object is in the rolling motion, when the object in the rotation motion, the torque produced by the external force is called angular acceleration. Okay, so we know that acceleration is nothing but rate of change of velocity. Angular acceleration is nothing but rate of change of angular velocity. Rate of change of angular velocity. Okay, so tau equal to r of sine theta, when the torque will be acting perpendicular to that force. Perpendicular to that force. Okay, when r of equal to r of sine theta will be equal to, see, theta will be equal to sine 90 will be equal to 1. So r of f equal to, we know that from the Newton's second law, f equal to ma. Okay, f equal to ma, and tau equal to the relation between angular acceleration and acceleration. The relation between linear acceleration into angular acceleration. Linear acceleration a equal to rate of change of velocity. Okay, but angular acceleration alpha equal to d omega by dt. D omega by dt. So the omega is nothing but angular velocity. So rate of change of angular velocity is called angular acceleration. The relation between angular acceleration and acceleration equal to a equal to, that means a will equal to r alpha. And what is mean by relation between velocity and angular velocity? That means v equal to r omega. Same like that, a acceleration will be equal to r alpha. So when we're taking that a equal to r alpha, so tau equal to r alpha, so m r square alpha. So now m r square alpha is nothing but m r square in rotation, I mean vector notation. So look at this one. The direction of the torque and alpha are along that axis of rotation. The direction of the torque in the direction of the alpha, it produces angular acceleration. Note it down. If the direction of the torque in the direction of the alpha, it produces angular acceleration. Okay, on the other hand, if the torque is opposite to the alpha, angular deceleration or retardation produced on the points. The term m squared in the equations. M squared in the equation called moment of inertia I. So what is the value of I? I is moment of inertia is nothing but m r squared. M r squared. Moment of inertia is nothing but m r squared. So the rigid body is made up of many such a point masses. Many such point masses. Hence the moment of inertia of the rigid body is the sum of the moments of all inertia of all individual point masses. Hence constitute I equal to summation of mi ri squared. So we can take that. Hence torque will be equal to rigid body can be written as torque will be equal to mi ri squared alpha. So I alpha. Okay, what is meant by angular momentum? The moment of its linear momentum is called angular momentum. In angular momentum, rotation motion is equivalent to the linear motion momentum in translation motion. Angular momentum in rotation motion equivalent to the linear momentum in translation motion. The angular momentum of the point mass defined as moment of its linear momentum. Okay, note it down. Moment of its linear momentum. Here we know that momentum. What is meant by momentum? Momentum is nothing but p vector equal to mass into velocity. Mass into velocity. Here we gonna learn about angular momentum. Angular momentum denoted by letter L. L will be equal to r vector cross p vector. Moment of is momenta. Moment of is momenta. So L is the in other words the angular momentum L of the point mass having the linear momentum p at the position r vector with respect to, so L vector equal to r vector cross p vector. The magnitude of the angular momentum could be written as L equal to rp sin theta, where theta is between that r and p. L is the perpendicular to the plane containing that, then we can write that one L equal to rp sin theta, r into p. The same the torque, there are two cases, r into p perpendicular distance. When we taking the sin theta, so r sin theta p, so r perpendicular to p. The angular momentum 0, L equal to 0 if the linear momentum 0, or if the particle at the origin r equal to 0. If the r and p are parallel or antiparallel each other, theta equal to 0 degree or 180 degree, then angular momentum will be equal to 0. The misconception, there is a misconception. The angular momentum is quantity that is associated only with rotation motion. It is not true. The angular momentum also associated with the bodies in a linear motion. Let us understand some same with the following examples. Okay, angular momentum and angular velocity. What is the relation between angular momentum and angular velocity? Okay, one of the 3-mark question. If an object is rotating in the circular motion, okay, there must be a radius, there must be a mass, there must be angular velocity will be acting. So what is meant by L? L equal to angular momentum will be equal to L equal to r cross p, or I can write rp sin theta, rp sin theta. Now theta equal to 90 degree, what will happen? So we know that p equal to mv, so theta equal to 90 degree. So what will happen? L equal to r mv sin 90 will be equal to 1, so into 1, that's it. Okay, so now L equal to r mv sin theta, so r mv. Here we can write what is the relation between linear velocity and angular velocity. V equal to r omega, v equal to r omega. Then I can write this one, L equal to r m v will be equal to r m r omega. So I can write m r squared omega. Now the m squared is nothing but your moment of inertia, so I can write L equal to I omega. L equal to I omega. Okay, so 5.25, the equation 5.25. What is the relation between torque and angular momentum? Torque and angular momentum. Tau equal to I alpha, right? Tau equal to I alpha. I alpha is nothing but alpha is nothing but rate of change of, that means angular acceleration is nothing but rate of change of angular velocity. Then what will happen? The angular velocity we can write as the omega is angular velocity, so we can write this di omega by dt. So I omega is nothing but your angular momentum, so torque will be equal to dl by dt. So for today this is enough. Inshallah and next week onwards we'll learn about remaining things, guys. Okay, thank you guys. Allah Hafiz.